Gallery view. All right. We should be live. Annie, that green screen background is amazing. I'm jealous.
Thank you. I actually made it myself.
You made the green screen yourself?
Not the green screen.
The galaxy.
Background. Yeah, I actually downloaded the data from Hubble and colorized it myself.
Oh, really? Oh, great.
Yeah.
What do you use for processing the FITS file? Did you just use the Hubble?
I use the FITS Liberator, and then I pull everything into Photoshop.
How did you enjoy that? Because every time I do that, it's misery.
Because I mostly do Hubble images, it is actually, I want to say, pretty easy now because I just do Hubble images. The moment I switch to a different telescope is the moment where I'm like, oh no, this is terrible. Please make it stop. So
right. Yeah. So that's my experience. Everyone is optimized on Hubble images. And my experience is using like the astrophotography work that I do. I have to use it's a color camera. And so the Hubble FITS Liberator gives me FITS trying to pull 3 separate color channels out of one FITS file, and it doesn't like it. So you have to sort of trick it to be able to do that. So
right.
Yeah, but it's good. There's there's some great tutorials. Judy Schmidt, Astro Geck on Twitter.
I have looked at so many. I used to follow tutorials pretty closely, but now because I'm just working usually with Hubble images, I'm like, okay, this is what I've done.
Yeah.
I know I have to do this, 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 and this.
I'm going to say hi to a bunch of people. Hello to Astro B, Ben Kalo, Bill Sugden, Bruce Feingold, Christian Woodland, David Brannigan, David Dunn, David Fairweather, Dusty Reichwin, Gordon Dewis, Janny Becker, Jessica Feltz, John Musk, John Victor, Johnny J, Jorn Albert, Nancy Graziano, Paranor, Snow Tiger 45, Susie Murph, and Zapfan. Hey, everybody. Welcome to this absolutely regular episode of the Weekly Space Hangout. Geoff, I didn't warn you that we take about 5 minutes before we actually get started to make sure that the streams are working. So
that's all good.
Yeah. But in fact, I think it's all working. And since we're running a little behind schedule, I'm going to try and make up some time. I'm going to try and fly this airplane a little faster and see if we can still
Captain Kane.
See if we can still reach our landing point at the right time. I know a lot of you have connections, so. All right, I'm going to get this set. There we go. Here's my intro. And let's roll. Hello and welcome to the Weekly Space Hangout for Wednesday, October 2nd, 2019. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about... I can't see what we're going to be talking about. Hold on. We're going to be talking about space toilets, upcoming events in astronomy, artificial intelligence in Earth observation satellite, and of course, we're going to have to talk about Starship, and then maybe some other stories. Joining me this week, we've got, I'm going to start with Nika Klimovich. Nika, welcome back.
Hi, hello.
Again, you are absolutely a trooper. It's like 2 a.m. there, 3 a.m. there. You should be sleeping. Yeah. I hope everybody deeply appreciates your dedication to science outreach, and so thank you.
Yeah, my mama, I don't think that she appreciates. She's still awake because of me, but it's good.
It's fine. It's all for the best. Let's see. We've also got Pam Hoffman, the Everyday Spacer. Pamela, welcome back.
Hey. Thank you very much.
Now, last time you were on the show, you were a special guest, and now you're a panelist, right?
Nope, first time ever on this show.
I thought we had you on the Weekly Space Hangout before at some point. No?
Oh, never.
Oh.
Thank you. I appreciate the offer.
Okay. Well, now you're a panelist, so it's gonna keep going.
Awesome. Thank you.
So for people who don't know, so who you run a website, Everyday Spacer.
Yes. And I show regular folks how they can do this stuff. That's what I'm going to be talking about. I don't have stories, just what's coming up in the future. And there's a really cool event. I'm really excited to talk about that one.
Yeah, those are stories. I would assign those as your editor. If you worked at Universe Today, we give them to Dave Dickinson. But still, telling people what's going to be happening in the night sky is huge. I think this is great.
Yep.
And we've also got Annie Wilson, a Planetary Science Institute communication specialist. I just mixed that up. Annie.
Hello.
And I just wanted to mention for everyone who's watching, not only are you floating in the middle of deep space, but you did all the graphics production on that galaxy, which is awesome.
Yes,
Yeah.
I did.
See, everybody, that's how you use a green screen. Everybody accuses me of using a green screen, and of course, we have no idea how to use a green screen. So, we just stand outside in the rain in a West Coast Canadian rainforest. All right, so we're going to be getting on with our special guest, Geoff Notkin. But before we do, I just want to give a huge shout out and thank you to our good friends at the Weekly Space Hangout crew. They are, of course, the community, the friends, who help executive produce this show. They help really with the panelists, choose the guests, set everything up. We just show up and do our job. So if you want to be a part of this amazing community, go to wshcrew.space. They will put you to work, make you an executive producer, and then you can request guests for this show. It's how it works. So yeah, go to wshcrew.space. And of course, a big special thank you to Nancy Graziano, who is continuing to work really hard to keep everything going. And we couldn't do this without you, Nancy. All right, let's move on to the special guest portion of the show, and that is Geoff Notkin, Meteorite Man. Geoff, how's it going?
Excellent, Fraser. It's nice to hear your voice and nice to see your team. I'm very impressed that you're offering executive producer gigs on space shows. I highly recommend any enthusiastic listeners who want to get in to the field to take advantage of that. What an offer!
I know. Well, see, the way this came about is at some point, I'm just one man, and I was organizing the various things that I was working on, and people kept saying, "Oh, you should have so and so on the show. You should have so and so on the show." And I just said, "Tell you what, you tell them you're the executive producer of the Weekly Space Hangout, and invite them to the show. And if they question you, I've got your back." And so far, I don't know. I mean, in the comments, anyone can tell me if it's ever misfired. But so far, I think we've had dozens of people in the Weekly Space Hangout crew reach out to all kinds of people. We've had the chief scientist at NASA, many amazing people, and they just agree to come on the show because they see executive producer and they don't know, who would say no. So there you go.
And who knew that you were going to be unveiling the secrets of the universe here? So here you've touched on two of the great secrets of existence and success. One is delegate, and number two is just pretend you know what you're doing.
Yeah. Show up.
Super. You are champion.
Yeah, exactly. Show up, ask, and who knows what'll happen. So, Geoff, for people who don't know, who are you? What do you do?
My current role is president of the National Space Society. We are an international grassroots space advocacy group that was founded in 1974. I am a science writer. I am a television host and film producer. I'm probably best known in the TV world as one of the two hosts of Meteorite Men, which was a science adventure show that ran on Science Channel and Discovery for 3 seasons. And I'm also a documentary filmmaker and producer, and I am founder and CEO of Aerolite Meteorites, as my great science passion in life has been the study and collection of meteorites. And in order to further that all-consuming passion, hobby, business, however you care to look at it, many years ago we founded a commercial meteorite company to help underwrite the cost of our expeditions and publishing work and so on. So like yourself, Fraser, I'm a busy lad.
Yeah. Well, I really feel like like chasing meteorites is like just the perfect balance. Like there's some science in there. There's a mystery. Often you're chasing various clues and hints about impacts that happen at some point. There's this feeling of discovery, and yet you are holding a chunk of rock or metal that came from space. So I'm surprised I'm not surprised that is a thing that you like to do, because it's awesome. I would do that.
And you'd be, well, as your previous listeners know, because we've spoken about this in the past, but last summer, you and I had the pleasure of attending a wonderful astronomy event in Australia, and we got to hang out and spend some time together. I think you'd be an excellent man in the field.
Yeah, I'm ready.
You strike me as a really good adventurer. Yep. You're determined, and yet you're pleasant. And you learn when you travel to some of the most extreme places on Earth, that the overall experience can be very much predicated by the people you travel with. And if you choose wisely in your companions, you can have a wonderful time. Yeah. If you don't choose wisely, you could have an awful time, or you could just end up forgotten or dead in a ditch somewhere.
Because you trespassed on the wrong person's land without asking permission. So let's talk about, I encourage everyone to collect as many meteorites as they can get their hands on. I've got a bunch. It's a wonderful hobby. Go to Aerolite. If you can't find one in the field, I'm sure that Geoff and team will be glad to sell you one. Let's talk about the National Space Society. So, you came on board as the president. I think I interviewed you 6 months ago or so, and it had just happened. You're still doing it?
Correct.
So it
yes.
Must have gone well.
Well, yes. Gosh, I've lasted half a year already. It's going very well. So yes, I was appointed in March, and I have been involved with the NSS for quite a number of years. I've been a member of the Board of Governors for 4 years, and each year, the NSS holds its flagship event, the International Space Development Conference, which we all call ISDC. And it is usually held in the US, but it's rotated to other cities. We've been in Toronto, we've been in Puerto Rico. And that's the big way in which we interact with the public on a large scale. This year it was in Arlington. Next year it'll be in Frisco, Dallas. And so that's our flagship event, where we invite prominent spaceflight speakers and astronauts and scientists, researchers, writers to speak and engage with the public. It's grown into a tremendous international event, and I highly encourage spaceflight enthusiasts and professionals to consider attending. It's a great opportunity to hear presentations on the latest tech, to meet other doers and innovators, and a very important component of our work is working with students, and in very large part international students. So there are a number of student spaceflight events that we partially sponsor each year. And I had the great pleasure of visiting one of them in July at Kennedy Space Center, and it's called the Space Settlement Design Competition.
Yep.
And I've been to a lot of student events. As you know, Fraser, I do a lot of student outreach and science writing, and I've done a lot of educational television in addition to Meteorite Men. We did a series called STEM Journals for several years. So I work with students a lot, and I work with spaceflight students a lot. But this event at Kennedy Space Center really blew my mind. It was one of the most inspiring things I've ever been part of. We had about 240 students, mostly high school age, from 6 continents participating at KSC for a long weekend. And they're divided into these teams, 4 fictitious aerospace company teams, and given an assignment to design a fully functioning lunar base, a lunar settlement. And they've got about 3 days to do it. So I loved it because I got to witness all of this.
Yeah.
Youthful brain power and enthusiasm in action, but also because I got to play a role. So I was a member of a fictitious organization called the Foundation Society that had commissioned this project. So I got to I got to visit the student groups while they were working and hear about their plans and ideas and give a little feedback. And then on the Monday morning, there were 4 amazing presentations by these students in their teens. And I know every generation has a tendency to look back and go, oh, kids today, they don't know anything. And I think we hear that a lot in our generation. And I'm here to tell you that that is definitely not true.
Kids are all
I
right.
was astounded by not just the intelligence of these students, but also their focus and determination and how well they presented and how well they thought things through and their manners.
Yeah.
And what courage it takes to come from another country. And many of the countries were not, English was not the primary language. So we had a lot of students from Romania, from India, and several from South America, some from Mexico, Australia, the UK, where there's no language barrier, but still extreme travel. And then for many of these students to go and present, to compete internationally in a country not speaking their primary language, I was so inspired. It gave me hope for the future, not just the future of spaceflight, but the future of humanity. To see that level of dedication and hope is really something. I highly recommend it to anyone who's interested in witnessing and encountering the next generation of spaceflight students.
It's interesting. Like, I think about things like that, like the original, like we keep talking about O'Neill cylinders today, even though that was that kind of an event. Like Gerard O'Neill gathered together a crew of students and people that he, you know, in a location, and they hammered out the mathematics of what it might take for humanity to live in space. And it has been almost codified into stone tablets that we continue to talk about 40 years hence. And those kinds of events were creative, out of the box ideas from people around the world who, you know, they're looking at these problems that are unsolved problems with absolutely fresh eyes. And it's hard not to get caught up in appreciating what the solutions are that they come up with, you know. And
you're so right, Fraser.
Yeah.
I think you've actually given the best description of it. It was the originality of ideas and problem solving that was really an eye-opening experience for me. And you asked about the National Space Society and our history, as you know, but not all of your listeners, your viewers will know that we're formed of two organizations that were originally founded by O'Neill and by Wernher von Braun. And so the two organizations merged into the National Space Society. And so we represent, on one hand, the O'Neillian idea of the space settlement, and that is a key factor in NSS belief and hopes for the future. But let's not forget von Braun, also the great rocket engineer, who was maybe more on the engineering side. And so we represent both sides of this, the tech side, the mighty rockets, and also the more humanitarian side with settlement and farming.
Yeah.
And aren't we really going to need both if we succeed in the long term?
And so, I mean, for the longest time, I looked at the work, like I've been aware of the National Space Society for so long, and it was hard to sort of see the really grand sweeping vision of the Space Society, the kinds of conferences that were coming together. And then to sort of have that in the backdrop of nobody's been to the moon in 50 years, the goals of NASA and the other space agencies are changing on a regular basis, so it's really hard to sort of see. And then on the flip side, now suddenly it feels like we're on some kind of, I don't know, rocket, and it's all going so quickly. Are you finding that are other people experiencing this? Because it's my job to stay on top of how quickly everything is changing, and I'm overwhelmed. I can't imagine what it's like to be, you know, trying to help usher some of these actual things into reality.
As always, you're a very astute commentator, which is one of the reasons that you're so successful in this field. You have great insight. So,
oh man, you're the best guest.
Oh, thank you. No, but it's true. I mean, you're an inspiration for listeners all over the world. And one of your great gifts, Fraser, is that you do have the knowledge, and you're able to convey the knowledge in a way that is accessible to everyone. And it's a rare gift. And it's one of the reasons that I enjoy your work so much, and I always love being a guest on the show. So thank you again for inviting me. Yes, you're absolutely right. That I feel this is not the official view, but as someone who's been a fan of the NSS for many years and am now a senior officer in the organization, I feel that the NSS helped keep the dream of spaceflight alive all of this time.
Yeah.
Many of our officers and longtime members and volunteers are themselves former spaceflight professionals. Several of our key officers work with NASA now or other spaceflight groups, and many are former spaceflight employees. And I'm fond of saying it's not just the club of enthusiasts, of people who get together and talk about how great rockets are. I mean, there's nothing wrong with that, and I like that because we like to share the topics that move us the most. But as spaceflight, and especially commercial spaceflight, has become so invigorated recently, so I have seen the NSS become invigorated with an influx of new officers. We're attracting some younger members and younger board members. And I feel that we ourselves have reached a point where we're embracing new technology. Mm-hmm. And many of my colleagues and I have suggested that we become more interactive, that we do video streaming of our events when possible.
Yes,
certainly,
please.
Well, yes. Well, we're working on it, and remember that we're entirely a volunteer organization. We have one or two paid employees who still give of themselves much more than one would expect for their salaries. But by and large, we're a volunteer organization, and all of our key members and officers have other jobs, and they donate their time. So in a large organization where there's a lot of passion and long-term belief, there are a lot of viewpoints to consider. But I know that the idea of streaming our conferences, at least some of the high points, is very popular. Our beautiful magazine at Astra, which is edited by Robb Report, who I know is someone you know well, yeah. The eminent space writer, has gone through a magnificent metamorphosis in the past 2 years. And I'm a columnist for the magazine. I've been writing for them for some years. And I am honored and thrilled to see it now exist as a beautiful professional magazine that everyone associated with it can be proud of. And that's one of the perks of membership.
I think your point is well made there, that that as we do rush headlong into this next stage, as when if the Starship flies, and if it is able to successfully return from orbit, and it is able to dramatically bring down prices, and we'll get into this in a second later on in the show, of course, then 10,000 details rear their heads. Where are people going to go to the bathroom? How are they going to store their drinking water? What about the radiation? Where are people going to live? How are they going to build their houses? What is everybody going to eat? How are they going to get enough protein, right? And you guys have been thinking about this and talking about this at conferences and writing papers and reporting on all of these myriad details. And so it feels like when Blue Origin and SpaceX get to the point where they need to start solving these problems, the groundwork has been laid.
Oh, I hope so. Thank you. That's a very generous comment and observation. And I think very related to that, something I should mention, in addition to ISDC, our big public event that we put on each year, we also host the Space Settlement Summit, which is a perhaps slightly more technical gathering, which is focused primarily on the needs, the short-term, near-future needs that we're going to have with moon bases and Mars bases and long-duration spaceflight. And that is happening November of this year, 13 and 14 at Caltech. And so that, to me, is an example of think tanking and brainstorming and addressing very specific issues, which hopefully will have far-reaching consequences.
I've got one last question for you. If you could hunt for meteorites any place in the solar system, where would be a place that makes sense to search for them? Because I know on Earth, we search for them in Antarctica. We look in the deserts, where you see a rock, a place there shouldn't be a rock. Where would be a better place to look?
Oh my gosh, I just love being asked a question that I've never been asked before. So I suppose what immediately comes to mind is Mars, which would be good and bad. And here's the thing to consider. if we go to environments like the moon that don't have an atmosphere,
Yeah, they smash up.
when meteorites land, they're just going to land in their natural state. They're not going to ablate into the fantastic shapes that we see when we look at meteorites like this one that have landed on Earth.
Right.
And to me, this is one of the things that makes them fascinating is the ablation, the melting that goes on in the atmosphere. So if, of course, meteorite fragments have been identified on Mars by the rovers, and moon rocks have been recovered by astronauts that had meteorite fragments embedded in them, the lunar regolith breccias. But so Mars immediately springs to mind, and here's why. It's got enough of an atmosphere that meteorites would ablate somewhat, so we would expect the surface to darken and for them to acquire a fusion crust. I can't do a video interview without a bit of show and tell.
Yeah.
For listeners who are not familiar with that term, this is a stone meteorite. This is actually from Chelyabinsk, the giant fireball that was seen over Russia in 2013. So the surface is being burned by the heat from pressure as it hurtled through the atmosphere. So when we're looking for freshly fallen meteorites, this is what we're looking for: dark surface that's being toasted in the atmosphere. So Mars should, I would hope, have enough atmosphere to create some fusion crust, but I think that red surface would be a really nice hunting ground.
Yeah.
So we're looking for unusual rocks that stand out on the landscape. Imagine if you were out hunting on a red surface.
Well, they have found some. So the rovers have found some metal meteorites on Mars.
Yes.
So it's been done. I'm also thinking like Titan would be interesting too, right? Where they come through the atmosphere. Gotta let you go, Geoff. Where can people join the National Space Society, get involved in your projects, and find out more?
Wonderful. Thank you for asking. So we are the National Space Society. It is nss.org. And we have introductory memberships at only $20 a year, which includes our beautiful award-winning print magazine, Ad Astra. And if you visit ss.nss.org, you can find out more on the front page about Space Settlement Summit, which is in November, and International Space Development Conference, which is in spring of next year in Frisco, Dallas. And you can find me online at Geoff Notkin, GeoffNotkin, at everything, on every platform, virtually. And my company is Aerolite Meteorites, and we are an international organization. We specialize in sale, research, and recovery of meteorites. And we are aerolite.org, AEROLITE.
Wonderful.
Thank you for having me on the show.
Right.
It's such a pleasure, Fraser.
Always a pleasure. We'll see you next time, Geoff.
Thank you.
All right, let's move on to the next portion, the news portion of this week's episode of the Weekly Space Hangout. Let's start. Annie, you're on my screen. Speaking of a million details that have to be worked out, let's talk about space toilets.
Oh, space toilets. All right, so right now there are 9 humans and 5 toilets in space.
That's right. Yeah, there's 9 people at the International Space Station. And how many toilets?
5.
5.
There's 1 on the Russian segment, 1 on the US segment, and because there's 3 Soyuz docked to the ISS, each one of those has a toilet in them. And they are not toilets you sit on. You straddle the Soyuz toilets like you're on a horse, or because it's October, a witch on a broom.
Right.
And they don't like using those toilets, but they're there, and over 140 of them have burned up in our atmosphere.
140 toilets have burned up in our atmosphere.
Over 140 toilets have burned up in our atmosphere.
Right. So each Soyuz has a toilet, and as part of the cargo disposal process, they fire that overboard and it burns up in the atmosphere.
Exactly. It is in the round module. I believe it's called the Orbital module, the one that has all the living space. And yeah, that's the same module that is filled with trash. And just it separates from the command module, and Orbital module gets burned up in the atmosphere. Command module brings the people safely home.
So why did you choose this as a time to talk about this?
Because I like space toilets, and this is the first time I was on, and I was told to pick an article. So Space toilets. This is a really weird rabbit hole I went down one day, and the further on down I went, the weirder it got. And now I just embrace it.
Yep. Yeah. So definitely, we're going to need more information here. So take us down this rabbit hole a bit on what you discovered.
So I started out looking at the Soyuz modules, and I noticed that, hey, in the orbital module, there's a toilet. How long has there been a toilet in the orbital modules? And pretty much since the original Soyuz capsule with people in it has been in existence, there's been a toilet on Soyuz, which is before the US got its act together and had a toilet, because
right.
Apollo, they did a urine venting system that sounded kind of scary. Mercury may have used an Apollo could have used that same venting system and potentially in bags, and one of those bags leaked and urine got all over the electronics, and that's why there was a manual landing of that particular craft. So
there was a manual landing of a spacecraft because urine leaked on the spacecraft. Correct. Right.
Correct.
I mean, I think, man, I am loving the comments right now. We don't want to let this topic hit the fan. I mean, I think people don't even realize like that whole part of NASA and the Russian everyone's space exploration is not a part that you are exposed to. But the the original astronauts, they wear diapers a lot. They still do.
No. The original astronauts did not wear diapers.
Oh, really? Okay, all right.
Maximum absorbency garments, as what they're officially called, did actually not come about until we had female astronauts, believe it or not. What the Apollo gentlemen did, there are these wonderful things called Apollo bags. It is clear plastic. It has adhesive on one end and a little kind of indentation into the plastic that they like to call a finger cot. You take the adhesive, put it on your rear end, use that little finger cot bit to help solid waste come out of your body because gravity is not there to do the work for you.
Gravity's no friend.
And afterwards, they had to put a capsule or break a packet or something with antimicrobial in it and massage their own waste in a clear plastic bag.
Yeah.
This was a design fail.
Yes.
I am convinced.
Yeah.
And sometimes there would be escapees. There are transcripts about astronauts talking about poo floating.
Yes. So, I mean, like, how much of the misery of space flight is dealing with the things that come out of your body?
Oh my.
Yeah.
Well, you can't burp.
Yeah.
You cannot burp because gravity is not there to separate the liquid from the gas in your stomach.
That's weird that you can't burp. Yeah.
You cannot burp. If you feel like you're going to burp, you might as well make sure you've got that sick bag because that's probably what's going to happen. Yeah, you can't burp. I'm not so sure about flatulence, but I wouldn't. I know that I think it's after 6 or 8 hours, all the liquid in your body, all the fluid in your body redistributes because of in microgravity, and it triggers your kidneys to tell your brain that you need to urinate. So yeah, if before that straight shot of let's get to the ISS using the Soyuz craft, yeah, they had to use the toilet in the Soyuz craft.
So what is the state of the art? What is the best case scenario if you're going to go to space and need to go to the bathroom? What is the throne that you want to go for?
The throne you want to go for is one of the toilets on the ISS, simply because that's your only other option aside from bags and the Soyuz toilet. You want that one. If I had to pick, I really liked the design of the toilet on the Skylab because it actually had a real toilet seat and you could actually sit down and kind of adjust yourself.
Right.
The toilets that are on the ISS don't have that nice wide toilet seat that Skylab did. And they definitely have to go through some special training to make sure things align. But yeah.
But this is, I mean, like it is not a solved problem at this point.
Oh gosh, no, no. They're still looking at technologies. I mean, even once you've got it figured out of how to get it away from the body, you still have to do storage. You still have to dispose of it. If it's, urine, they drink recycled, essentially. They process the water in such a way that, yes, astronauts are drinking recovered water. So recycled urine, recycled sweat, condensation from breathing during exercise. This is all real stuff. And if we're talking about going to Mars, to anything far away, it's like, what are we going to do with this waste?
What are we going to do with this waste? Like if there's one reason to build some kind of artificial gravity system, it is purely this. Like, just like then you get back to good old gravity and, and then you're set. But, well, that's wonderful. Thank you so much for bringing this to our attention. And feel free to bring us along on any of these, rabbit holes that you go down. Absolutely fascinating. Let's move on though. We're running out of time. I want to make sure we get a chance to talk about all the stories here. Nika, you're on my screen right now. Why don't you tell us what you got?
Okay. After toilets, my topic, artificial intelligence in space, sounds really boring. But I didn't get it. So do they throw away all the toilets? Like, why would they throw away the whole toilet? Or is it something, or just the parts that they don't need?
No, they throw away the whole toilet. The whole thing.
Yeah.
The whole thing in the Soyuz part is just gone.
It's
gone.
And
it's stored in a cabinet, by the way.
To be fair, they throw away the whole spaceship.
Yes.
That has the toilet inside, that has the waste inside the toilet. Like,
Okay. Maybe artificial intelligence will be able to help somehow to solve the problem of the toilets. Who knows? But currently they're solving other problems. So the topic that I'm going to talk is like there is in a few months from now there will be a small satellite launch to demonstrate how basically the onboard artificial intelligence help improving the efficiency of sending Earth observation data. So, and by the way, this technology, artificial intelligence technology, which is called PSAT, was developed on one of this kind of conferences that George and you talked before, where the students come and or the people from other industries come and discuss some topics. And there was basically how digitalization combined with the satellite data can do something good for businesses and science. So that's how this technology actually was was a spin-off. And basically this technology will fly on one of the two CubeSats. It's like this big, shoebox size, and the mission is called FCC CAT mission, and they will try to basically gather the data on ice and Earth moisture. And it is intended, this mission, to complement Sentinel Fleet. And the Sentinel Fleet is the constellation of 6 families of satellites. Of course, they are not intended to complement the whole fleet, but maybe the parts of it, using really small satellites. It's fascinating for me every time when I hear it. So yeah, and the CubeSats will have optical instruments, and the hyperspectral camera will collect a lot of images of Earth. But not all of the images are suitable for use because of the cloud cover. So basically, many of these images will be just gray. So what is this artificial intelligence is doing? This chip is filtering out the basically gray clouded images that you don't need and just sends the data which is useful. So of course it's, yeah.
Oh, I was going to say, yeah. So, I mean, this idea that, you know, one of the most complicated parts of having a satellite is communicating with your satellite. You can actually get I actually looked into this a couple of years ago, like what would it take to launch a satellite? And it's, you know, those small CubeSats, there's even nano CubeSats, like just a little slice of like one slice of bread. You can take satellites that small now. But the challenge is being able to communicate with your satellite because it's going around the Earth. And so if you can minimize the amount of data that you have to send back home, then that allows you to just focus on what's important. So that sounds like a really great implementation of artificial intelligence or machine learning for a satellite.
Definitely, and I think it has to be on every single satellite. Like it's a little bit off topic, but like Gaia, yeah, it has so much amount of data. And I was trying to find whether they were using some artificial intelligence to filter it out. And actually, I don't think that they use artificial intelligence. They have some filters. But imagine if you implement the artificial intelligence on that, and imagine you can actually kind of command this artificial data or communicate. So basically, there are so many possibilities with these technologies. And of course, you can implement some of the thinking artificial intelligence on the big satellites. But imagine bringing it to these kind of sizes is just crazy. So you can do so much with it.
I mean, a similar take on that is like the Kepler satellite, you know, the space telescope that was used to find exoplanets. It would image a chunk of the sky and it knew where all the stars were. And then it would take light readings based on all of the different stars to find out whether or not there was a planet there. And because its gyroscopes went offline and it wasn't able to point itself around in the sky, it wasn't able to do its work. And part of it is that it was actually doing a lot of the processing on its own, and then it was sending the relevant data back to Earth as opposed to just dumping gigantic images. But that idea of Gaia, I don't know if Gaia is doing any image processing or it's just sending all the basic information back, and then they're doing all of the astrometric data processing here on Earth. You actually got a chance to see a lot more presentations from Gaia and other spacecraft, right?
Yeah, that's true. And actually, I read something on it. So basically, they did some kind of filtering, or not prioritizing, like important information, unimportant information. And basically, when they have this 8 hours window, they send all important information first, and if they have time, they send the rest, basically.
Yeah, and you can really imagine this, you know, a future where you've got some spacecraft on some other world, and it is minutes, hours away by the speed of light, and it has to make decisions, or it gets smashed. So, makes sense.
Yeah. There were so many applications on the conference that have been with the artificial intelligence, like the same as like investigating or mapping the landscape of Mars or Moon using several of this kind of small rovers. And they somehow have to understand where the other one is and which direction should I go. And this is all done only by using artificial intelligence. So you cannot otherwise control all of them, or you do it manually from Earth, but it's really not efficient.
Yeah, and especially when you've got these limited windows to communicate with your satellites. So the more you can put the intelligence onto them, the better. Very cool.
So basically, the automate the decision making, and hopefully that is the future.
Yeah, I think, you know, we experience this kind of machine learning enough in our own day-to-day lives. It seems kind of crazy to not have, you know, some of this other stuff. Any mumbling, Bennu?
there's been people asking why we can't use artificial intelligence to mark all the rocks and boulders on Bennu. I don't like Bennu. That's about all I can say. I don't like Bennu. It's too complex for AI to do it. So
today or ever, we'll see.
I don't know.
Yeah.
Hopefully someday it can do it, but oof.
Yeah, that was a rough. I know a lot of people put in a lot of work for a lot of time to try and get to that. Thanks, Nika. And I mean, it's great that you got a chance to actually be at that conference and see a lot of these presentations. I think, for people who never have these like, people will read press releases and see things that are happening, things that we report on and other websites are reporting on. But that's just the tip of the iceberg from all of the really interesting material that's being presented at a lot of these conferences. So I highly recommend attending them when you can.
Me too, but they're so expensive for not students. That's why it's I don't know, but it's like the Geoff said, it's so inspiring. You're just like, how would these people come up with these ideas? So I am actually confident that they will map the venue. And
the trick is to go as a journalist. So you get your press credentials, then you get to go for free. I mean, you still have to get there, but and then you're reporting on it for the Weekly Space Hangout. So,
that is my hope.
Keep that in mind. All right. Pamela, tell us what we should be getting prepared for in the night sky.
Thank you so much, Fraser. And just so you know, I ran an International Space Development Conference once. So,
and you lived and you're still here. So,
I recovered. Yes.
Yeah.
All right, so we have a bunch of meteor showers and a transit and a couple other things in here. Tuesday, October the 8th, is the Draconids meteor shower. And this is unusual because the best viewing is actually early in the evening instead of midnight on. The shower runs annually from October 6th to 10th. It peaks this year on the night of the 8th. The first quarter moon, however, will be a problem until it sets shortly after midnight. And you definitely want to look for a dark site for this kind of thing. Only the very brightest meteors will appear otherwise. The meteors in this case will radiate from the constellation Draco, but they can appear anywhere in the sky. And that goes for all of them. Sunday, October the 20th, Mercury is at its greatest elongation. This is the best time to view Mercury because it's going to be at its highest point above the horizon in the evening sky.
I still can't see it.
You want a really low.
I have a mountain to my west, and so I have never seen Mercury here. I saw it when I was visiting Pamela, the other Pamela, in Illinois, and we had a view to the west, and I was able to see it. And I was on a cruise ship once, and I could see it, but from where I live, we can't see it.
Yeah, you definitely want to look for it low in the western sky just after sunset. I have seen it several times. We have a really decent location out here for observing, and we can see that kind of thing there. Monday, October the 21st into the 22nd is the Orionids meteor shower. These produce about 20 meteors an hour, and these are from the dust grains of the Halley comet. This is going to also have a second quarter moon issue, but again, some of the brighter ones, and these do have bright meteors. They're going to still appear for you, but you definitely want to look for a dark location away from city lights, and in this case, after midnight. These meteors will radiate from Orion, but they can appear anywhere in the sky, like all of them. Sunday, October the 27th is a new moon, and this is a good time to observe because you can see the faint fuzzies, stuff like globular clusters, open clusters. I really like those kinds of things. Also on Sunday the 27th, Uranus is at opposition. It's the closest approach to Earth, and it will be brighter than at any other time of the year. It'll be visible all night long, and due to its distance, it will only appear as a tiny blue-green dot in the most powerful telescopes. A little bit hard for amateurs, but if you do get a chance to see a really great, aperture through it, like up in Mount Wilson, that's a 60-inch telescope. That's a great time. That's a good object to go for. On Tuesday, November the 5th into the 6th, are the Torrid meteor showers. This actually consists of two different comet tails. This is the meteors are produced by the debris of a comet tail, sometimes ancient ones. This has two of them, funny names, Asteroid 2004 TG10, and the other one is Comet 2P and Enki. The first quarter moon will set shortly after midnight, which makes it good for, the dark, for meteor showers, that kind of thing. Best viewing again after midnight. Let's see. And these can radiate from Taurus. Monday, November the 11th. This is the really special event. It is a rare transit of Mercury across the sun. So, viewers with telescopes, and you must have a solar filter. Please, please be careful. You can't feel any damage in your eyes because you don't have nerves.
Yeah, because they're on fire. Yeah.
You just can't feel that. So you want to be very careful and protect your eyesight. Use solar filters. This is an extremely rare event that occurs only once every few years. The next one will not take place until 2039.
Yes.
Now, this is going to be visible throughout all of South America and Central America and parts of North America, Mexico, Europe, the Middle East, and Africa. I love to bring these kinds of things because we have a worldwide audience, apparently. So the Eastern United States, Central, South America, those are the kind of best viewing sites. Sunday, November the 17th is the Leonids meteor shower. I told you there were 4.
Yeah, this is the good one.
Yeah, well, you hear about 2 a year. In fact, there are 900 meteor showers, about 100 of them they've confirmed, and we'll hear about 2 of them on the news. Leonids are, every 33 years, they have just hundreds of meteors per hour, like a real shower. I really want to see that. But normally they produce about 15 meteor strikes per hour at its peak. The last one of the big, meteor cyclonic peak, they call it, occurred in 2001. So we have a few years to go.
Did you see it?
No, I've never seen this.
Oh, really? I did. So I saw the 2001 meteor storm.
Yeah,
and it was absolutely stunning. Like it was just, it was many meteors a minute. Like you were looking up and you were seeing meteor, right? It just,
cool.
It felt like, a meteor every couple of seconds. So it was definitely one of the most impressive space-related events.
I'm so jealous. I mean, even when they say there's 60 an hour, that's 1 a minute. Think about waiting 59 seconds for anything. At this point, with the computers we have, it's like crazy.
Yeah.
So this is from the dust grains left behind by the comet Tempel-Tuttle. That was discovered in 1865. They usually run from, and the peak is just when you'll probably see the most, as predicted. But these, like in this case, this runs from November 6th to the 30th. But it'll peak on like the 17th into the 18th. In this particular case. The second quarter moon is going to block many of the fainter ones, but you'll probably catch some even so.
Do we know when the next big storm is going to be for the Leonids?
Well, they talk about 33 years, so I would say,
another
2034.
Perfect. I'll still be doing this job, no problem.
Put that on your calendar, right?
Yeah, exactly.
I'm gonna. All righty. So Sunday, November the 24th is a beautiful conjunction of Venus and Jupiter. If you've ever looked at these two together, it's just stunning. They're going to be 1.4 degrees apart in the evening sky. So look for this just after sunset. I've actually seen these planets even when the light is still kind of bright. I kind of challenge myself, how early can I see these big bright planets?
Whenever this happens, I go onto Twitter and I will as quickly as I can answer questions about what those two stars are in the sky. And people the gist will always be, how come I never noticed those bright stars in the sky, or something like that? And I'll go, that's Venus and Jupiter. That's Venus and Jupiter. That's Venus and Jupiter. And I'll just do like nonstop. I'll just answer it again and again and again. Sometimes, hundreds, sometimes, hundreds of times, because it's just like, it's this moment where a person is like expressing some curiosity about the sky, and I gotta jump in there and help them out and get them enthusiastic. And I
love that. I love that. Yeah. All right. So the last one I have here was Thursday, November the 28th. And in the United States, that's Thanksgiving. Mercury will be at its greatest western elongation. This means it's the best time to view Mercury, since it will be at its highest point above the horizon in the morning sky. So that's when you're going to want to look for it in the morning.
I got mountains in the other direction too. So
oh no!
Yeah.
Go to the top of the mountains.
Yeah. There you go. I will climb that mountain in the closing in on the wintertime and enjoy that dot on the sky. But for everybody else,
it's fun. It's fun to find these things like Mercury. And that's what I have for now, because I'll be on again and I'll bring out more of these cool things for you to look at. I think the peak one for me is going to be that transit.
Yes. Well, that's huge. I mean, do you remember I think I'm going to try to figure out a way to live stream it. So I'll keep everyone stay posted, and I will try and figure out a way to make that happen. All right. So we've got just like a little bit of time left, and I want to, of course, show everybody or talk briefly about the presentation that happened on Saturday. Now, I did a video about it. And this, of course, was Elon Musk presenting an update on Starship. And the key here was that he was standing in front
at 25 times the speed of
Starship as he did it.
Miles an hour.
I'm going to show my
stationary
co-host so they can see.
And since there's no air, you don't have to have an aerodynamic structure. So you can be a totally crazy structure that doesn't look like it should be able to go 25 times.
Anyway, it goes on for an hour and a half. And so, allow me to give you the short version of this. And that is, of course, that they've got a 50-meter tall spaceship built in Boca Chica, Texas, and it's going to serve as the prototype for the next generation, the next set of tests that we're going to try to do with the Starship. So of course, the big change, they built it out of stainless steel. It is for a fraction of the price it was going to cost with the carbon fiber composites they were originally doing. So it is there in Texas. Probably in the next month or two, their plan is to take this one and have it hop for 20 kilometers and then have it come back and land safely on the ground. They are at the same time building another one over at Cape Canaveral, and they're going to sort of do similar tests from that site. The medium-term goal is to actually go to an orbital flight sometime. Rebecca was saying they took it apart again. They're going to try to go orbital within about 6 months, and he figures that humans will get on board sometime next year. Now, of course, this is all in Musk time. And so we know that the timelines that Elon Musk says don't necessarily work out to them in reality. And at the same time, there is a 50-meter spacecraft made of stainless steel, and it's right there. And we saw the Starhopper prototype make its hop just a couple of months ago, demonstrating the capability of this Raptor engine. So some of the interesting new design changes before it had 3 wings on the back that also served as landing legs, and now it's got these 2 little flappers. I'm calling them wings. People say I shouldn't. So they are air brakes. And so the goal is, as the Starship comes through the atmosphere, it's going to be belly flopping into the atmosphere, trying to bleed off a lot of that velocity. And it's got these little flappers at the top and bottom that will sort of maintain its position as it's coming through the atmosphere, through the thickest part of the atmosphere, and then when it's bled off most of its velocity, it's going to kick that bottom around and land propulsively. And the scale that he was describing, and again, there's, I don't know how much of this you can take that seriously, that they're going to build the super heavy booster, which is going to be the part that it's going to be stacked up on. These things are going to launch. In theory, the super heavies could go 10 times a day. The starships could go 4 times a day. That one Starship and super heavy booster could launch 1,000 times as much cargo as the rest of all of human spaceflight combined every year. So it's all bonkers, and we are in this moment where we don't know if this is real or not. And I think that we are going to find out in the next 2 months if any of this is actually going to take things to the next stage. If we watch this Starship take off, land, okay, fine. Now a bigger water tower can fly to 20 kilometers and land safely on the ground. But if we actually see some orbital flights and this thing is able to actually return through the atmosphere, land safely, then we are, then I think we will have crossed this chasm, and that we will, for the first time in human history, have a fully reusable orbital class rocket vehicle. And I can't wait to see what happens next. I mean, it's funny because everyone gives me such a hard time for being such a skeptic about all this, and yet I am just I'm so excited to see what happens next. Did any of the rest of you, what do you think? I did a video and I asked people to tell me what they thought, and I would love to hear your bets. So Annie, I want to start with you. Place your bets. When do you think an actual starship will return from orbit safely and land on Earth?
5 years.
You think 5 years? So not
5
6
years.
months, 5 years.
No.
And I think that fits the math. I think if you chart the timeline of Falcon Heavy and Crew Dragon and the original Falcon and their attempt to land, that seems to match. All right. Okay. Pam, what do you think?
I did not see this. So this is going to go where and then come back?
Space.
Just space, because it's all space,
Yeah, no, it's gonna. I mean, the trick with the Starship though is no part of it gets thrown out, right? With current rocket launches, they smash up in the atmosphere, and the whole thing, the whole stack will go to space and return. Nika, what do you think?
I will be optimistic. I would say 2 years.
You think 2 years? All right.
Just for being optimistic. Considering that the Europeans are thinking of reusable rockets as well, and they are planning to send it to space in 20 years.
Yeah.
So I want to be really optimistic. I know that you guys do it in 2 years. Yeah. It would be amazing.
I mean, if Starship flies, then everybody's plans for their rockets are out the window. SLS just gets canceled. Ariane 5, 6 canceled. It's going to be bizarre if this thing works, which is why I think Annie's probably, even Annie's predictions feels a little overly ambitious. It's that crossing back through the atmosphere part that is madness. That is to go from 28,000 kilometers per hour to 0. That's difficult, and we've seen with tragic results if it goes wrong. So I wish it goes as quickly as possible, and I wish them all the best. All right, reached the end of our show. I'm going to put everybody on the gallery. There they all are. Thanks everybody for joining us on this week's episode of the Weekly Space Hangout. Nika, where can people go if they want to find out more about what you're working on?
Okay, actually, I did Twitter.
You did it.
Account finally. There's just one post for now, but I promise to work. Yeah,
Perfect.
basically, I will try to keep on touch on Twitter and post there what I'm doing.
Okay. Well, we'll put a link into the show notes. What is your Twitter account?
I think Veronica Space.
Veronica Space.
I will link send the link.
All right.
I just created it and posted one post, so I literally forgot the name.
All right. Anywhere can people find out more?
I am Binary Ablaze on Twitter. I mostly tweet about my dogs.
There we go. Right on. And Pam, where can people find out more?
Amazon. I just published a book.
Oh, great.
Part of your amazing itty bitty series, and in my case is Explore Space Now, 15 ways to participate. And the book is just slightly longer than the title, but yeah, I'm on Amazon.
Perfect.
Thank you.
All right. Thanks everyone for watching. Thanks to my co-hosts. Thanks of course to Geoff for showing up and helping us out. Thanks to the Weekly Space Hangout crew, everyone moderating the comments. We will see all of you next week. And I'm sure this cutoff is going to be really weird, and I apologize, but I have no way to know when the stream gets cut off. So I'm just going to keep talking, and then it's just going to get cut off at some weird and inopportune time. Thanks, everybody.